Hello guys, in the previous lesson we have obtained the estimation rule and as well as the controller design rule based on the Lyapunov stability theorem. Okay, and so in this lesson we will create the Simulink model, which including two controllers and both the estimation model of the R system. Okay, and so in order to open the Simulink model, I push the Simulink button in here, and so I create the blank model at this moment. And so pushing the right click, and we need to proper set the model configuration parameters in here in order to obtain the solver selections. And so fixed step is selected in here like this one, and 1 E minus 4 should be selected. Okay, and so in order to add any function or body in here like this one, we need to give the some Matlab function body in here, and so this should be created to a real system. Okay, and so if I open this console right now, and then the x dot should be given at the output of this function. And so this is the real name of the real system like this one, and then we need to get the two parameters in here, x and u value. Okay, and n should be given at this moment. Okay, and so if I save this code where we're non-line estimation controller internet should be given as a name of this file. Okay, and so we have two parameters in here. The output section is given with the x dot is equal to the minus a times x plus b times u. Okay, these are the real system. And so we should estimate the values of the a and b at this moment. Okay, and so the system coefficients can be given by the arbitrary number, a equal to the 10, b equal to the 20. Okay, 21. And so if I have this information in here like this one, and so we can give the integrator value in here like this one. Okay, because this integrator value is given in the in the parameters of this nonlinear system at the initial condition. Okay, and so I can use the goto block in here like this one in order to simplify the R system. And so x can be obtainable right now by using the from value. Okay, and also we need to fed the proper u value in here. Okay, and then if we have this kind of parameters in here, and also we need to add another Matlab function body in order to estimate or imitate the real values of the a and b. Okay, and so if I open this selection in here like this one, we will have the z dot value in here, because the z is also contained the x hat, a hat and b hat, and so this is a vector of the 3 times 1. Okay, and also we need to fed this function body to z and real estimation or real measurement values of the x and u value. Okay, and so this is the estimator model in here, and then we need to create or calculate or build the Lyapunov stability rule in the estimation model which I have obtained in the previous sections. Okay, And also we need to give the error values of the R parameters in here, like this one. Okay. And so if we have this information in here, and so we can build the A hat and B hat value in here by using this rules value. Minus gamma times E1 times X square. Gamma times E1 times U. Okay. These are the basic proportion of the what the R system body. Okay. And so if I have this kind of parameters in here, firstly we need to obtain the state variables in here, like this one. X hat is equal to what? Z11. A hat is equal to the Z21, and B hat is equal to the what? Z or Z3, 1. Okay. And also we need to obtain the error estimation value, or E1 value in here, X minus X hat. Okay. And we need to give the stabilizer coefficients in here, like this one. AM is equal to the 1000, and gamma is another learning parameter in order to estimate the proper values of the R system. And so the output value should be fed with the what? X hat dot, A hat dot, and B hat dot. Okay. And these are coming from the what? The A hat and B hat value. And also we have the another kind of parameters which is given in here. X hat dot is equal to the what? The minus AM times X hat plus AM X minus A hat times X squared plus B hat times U. Okay. And so I can give the A or minus AM times X hat plus AM times X minus A hat times X which is given in here. Okay. And so plus B hat times U. Okay. U coming from the what? The R controller proper implementation of the inputs, because this Lyapunov stability tracks the whole reference signal in here, and so U is produced by using these rules. Okay. And so I can use this variable because the completion or the computational process is written in the what? Microprocessor structure. Okay. And so A hat dot is equal to the what? A hat is given in here, minus gamma times E1 times X square. And so minus gamma times X times error estimation, and also B hat gamma times U times error estimation. Okay. And also we can give the output matrix in here, like this one. Z dot is equal to the what? The X hat dot, A hat dot, and B hat dot. Okay. And also error output value is equal to the what? The error estimation values. Okay. These are the basic proportion or the procedure of the what? The estimation of the R, A, and B value in the system identification process. And so we need to fed the what? The proper values in here. Okay. Firstly, I can copy off these things in here, like this one. And integrator values is given by with the what? The 3 times 1 vector in here. First vector element is the X hat, and so 0 can be given in here, and A and B arbitrary numbers but not a 0 value, because if we have the 0 value in here, and so we don't have any process in the dynamics. Okay. And 1 and 1 can be given at this moment. Okay. And also we can copy of these things. X should be changed with what the z value in here, like this one, and so z can be fed into this term. Okay, and also we can use the x value in here, like this one. This is the easiest way to transmit any signal in the Matlab Simulink process. Okay, and also we can give the u value in here. Okay, and we should give the error value in here, like this one. And so if we have this kind of information in here, and we don't have any u inputs in here, and then we don't have any dynamics in here. Okay, because the zero value gives the initial condition, both initial conditions are the zero, and so the system does not have the dynamics. Okay, I'm trying to open, and so the zero value should be given in here, because the x dot value or x is always 0. Okay, and then in the next lesson we will create the controller rule in another Matlab function body. Okay, and so I need to change this name, estimator model, like this one. And so in the next lesson we will create the Lyapunov stability rule on the reference tracking problem. Okay.